see some of those papers over there. People in the past have understood the phenomena in the sky. Now they've interpreted these phenomena and what role the sky played in their cultures. And there's many associated disciplines with archaeoastronomy, such as anthropology, archaeology, astronomy, comparative mythology, theology, and ancient cosmology, as well as the myths associated with that practice. Furthermore, archaeoastronomy concerns the astronomical significance of ancient observatories and sites, and how ancient cultures form ideological associations from the sky and interpret a greater purpose or meaning within the sky in reference to their sites, as if there's a myth or association or meaning to life through the cosmos, and how it relates to us as humans and what we can discover from it. So furthermore, I will address, this is the plan, the initial plan of the presentation, which I'll address the questions and skills and knowledge, right? So first of all, I learned about the astronomical significance of ideas present in ancient civilizations, as well as the belief systems and patterns associated with that. And my main question I'm trying to investigate is why and how does cosmic symbolism express in architecture, in philosophy, and belief systems in ancient cultures? Why is it meaningful? Why does it give purpose for the cosmos and us as humans? And why is it beautiful? Right? These are the main ideas I'm trying to address. And third of all, I also share my notes and research observations. The notes over there is one primary example of what I have done. I've also made various presentations where essays, diagrams, all sorts of things related to that topic. So here's my presentation plan. First of all, I'm going to address astronomy as the nature of what the sky needs, and relate that with, so I'll address the nature of the sky and relate that with myth and stories, how we as ancient peoples have created myth from the sky. And part 2 relates to the sites themselves. It relates to the creation of sites and how they have an astronomical purpose. So looking through the eyes of our ancestors, so essentially our ancestors interpreted 2 major things from when they first came and what they first observed in the sky, and that is the equinox sunrise and sunset and solstice sunrise and sunset. And so the equinox is the time of day which night and day is the same. And solstices is when winter solstice, the day is shortest, and summer solstice, the day is longest. So as the sun rises through the sky, it makes an arc, right? It rises in the east, sets in the west. Therefore, you have the sun rise at a certain angle, right? And this is the trajectory of the angle of the sunrise. And the angle based upon summer solstice is actually going to be smaller than the angle for winter solstice, because the sun has to rise quicker or slower depending on the length of the day, and you can see that over here. And also the position of the sun changes as well. And you can see the same thing with sunset as well here too. And so if you plot this in a 3-dimensional sphere, it looks like this, right? That orbit, we take this outward and project it upward. The sun rotates like this, circular. And you can see this is called the sun's annual motion on the ecliptic, because you can see this is an ecliptic, and this is how we perceive the sun orbiting, or rather, around Earth yearly. And therefore, if you look at the sun over here, you can see the orbit of Earth is elliptical, right? So therefore, it's not circular. This Earth rotates faster on certain parts of the orbit and slower on others. There's also a 23.5 degree angle of precession, which means that Earth is tilted slightly towards the sun, right? So it's not totally straight. And you can see the solstices are opposite of each other. Here I already explained. In 5, if we look at the patch of the sky like this, right here, right now, and we want to see the sun over time, right? We can plot the specific points in the sky where the sun rises, and that's how that would look like, right here, if we just plot the sun. So time governed by the cosmos. Now, it's not just the sun which follows this type of pattern, it's also the stars, right? Around us, we have stars that orbit seemingly around Earth, as if the Earth itself kind of shifts the way that stars are seen from our perception. And you can see these as constellations. And this was a theory actually mentioned in ancient cultures as a band of sky. The sky, the constellations, was a god itself, as a band surrounding Earth. But now we know it to be like this. Earth orbits around the sun, and at various points on the orbit, we see specific constellations, and the sun can actually block the view of some of those constellations as indicated by these vectors over here. So if we look at this over here, this is this applied as a cubic function, right? So it's the same orbit, but this shows what constellations we can see various times of the year, the solstices, equinoxes, etc. And this, and 4 over here shows obliquity of Earth. This is an exaggerated example, but Earth's orbit changes. It's not the same around the sun every year. And because the orbit changes, Earth can move faster at certain parts of its orbit, right? And that movement of being faster relates to this diagram over here, which kind of relates to something called retrograde motion, based upon how fast Earth orbits around the sun. You know, if it orbits faster, we get less daylight, and therefore less heat, because there's less direct contact with the sun. It depends on how fast it's orbiting around the sun, how much direct contact it gets. Therefore, in winter, there's less sunlight. Over here shows a diagram of Earth as if it's top down. This here is the pole, where the northern star may lie, right? So which barely rotates around Earth. It's mostly fixed, unless based upon precession, which Earth wobbles slightly like this over time, which is the only reason why the North Star might ever change position. The constellations around it are not fixed, and they orbit like that. You can see that over here, how we can see the constellations relative to the orbit of the Earth. Cosmic order and chaos. Now I'm going to tell you a little interesting story of how they associated the stars with the orbit of Earth, because Osiris was an Egyptian god. He represented the livelihood, the vitality, fertilization. He represented the nature of civilization in Egypt. He brought order to the cosmos, or order to the people. But his brother Set was a conspirator. Brother Set wanted to kill Osiris. He was associated with chaos and desertification, opposite, doppelganger of Osiris. And so what happened is Set killed Osiris. And there's an interesting connection to this in the sky, because by tricking Osiris to sit in the box, he was slain and put into the river. Osiris is associated with the moon, and this happened in the 28th year of Osiris's reign. The moon has 28 days of cycle approximately. There's waning and waxing moons. If it's waxing, this means the moon gets larger. If it's waning, it means it gets smaller. As you can see here, these are 14 different gods going up steps to the full moon, right? This is Horus, this is the full moon. And that represents the increase to the waning moon. But on the day when Osiris was killed, it was going into a waxing moon. The tide was lowering of the Nile, because the tide is associated with the moon, and Osiris is associated with the Nile. He's even put in the Nile. You can see all these connections. It's fascinating. And so what happened was that Osiris's body was in the water and transported in the underworld as he was dead by Mat, the river, underneath the ground. And his sister and wife, Isis, followed him through this journey, and trying to find his 14 dismembered parts of his body, trying to put them back together, restore life and order to the cosmos. And so from his body they grew grain, and they brought order back. And this shows why the Nile essentially weakens and has a lower tide, recesses every so often, and that is attributed to Osiris's death. So eventually Sirius, which is associated with Isis, and Orion, which is associated with Osiris, fall beneath the sky. This is once it's over, right? Once we know that the flood is over and the death of Set no longer becomes an issue. Set's constellation, Set killing Osiris doesn't become an issue anymore. Set's constellation, Big Dipper, is actually opposite to these at the time. So Set's constellation essentially becomes independent of this, and Osiris and Orion and Sirius can follow their search without being confronted by Set in the sky as well, which has that other symbolic meaning. But ever so often, after 70 days, Orion and Sirius fall beneath the sky. The sun becomes too bright to actually see Sirius in the first place, and it's gone. The story ends, and then 70 days later, it begins again. That was too long, but it's okay. Circle of the sun. So here's a more typical example of archaeoastronomy. You can see, let's say, a sun circle. What happened here is that the sun has specific shadows which it can cast upon these poles, and based upon the size of the shadows, we can tell what it is. So it's a summer solstice, sunrise, etc. right? So in Cahokia, they tried to make this circle. It was not perfect, so they introduced this Backsight, which is 5 feet removed from the actual center, in which this is where they view the shadows, and supposedly had a quasi-accurate perception of the solstice because of the shadows that were cast by these poles when the sun hit the top of them. So specific poles assigned to the solstice. Now a platform for the sun. This is my favorite, one of my favorites. So what happened here, right? So you have the island of Jura. You have a big line that comes right through. And this right here, so you have something called the Paps of Jura. So this is a mountain, right? And these two mountains have a notch. And remember what I told you about the angle of declination that the sun has, right? For winter solstices and things like that. Well, it just reaches just the right point where the angle is steep enough that when it hits that notch at a specific point in time at night, the sun glows, right? It glows more and then immediately goes dark. Like a sudden burst, a gift of God, some sort of stellar inspiration, right? And so these typical things are used to actually make this apparent, and that's called a menhir. You see this in Stonehenge, a standing stone. Cairns, which are heaps of stones, which resemble some sort of religious purpose, and Krist, compartments around this religious menhir, which is a guiding stone to align with that trajectory. And over here you can see this sort of, this curve, which resembles what I explained about the sky over there, and how the sky, actually the sun makes its loop around the sky. And you can see the different angles here. And there's obviously this menhir, this stone, you align with it, but you have to stand further back to actually get the full perception of what the sun, what the sun is. So that's called a Backsight. And that's the same example that happened in the sun circle. You have a viewing platform further back where you can actually observe this happening. Shadows from the sky. So now this is a more typical example. You might find this in Central America. This is actually, and this particular example is in Chichen Itza. And what happened is that they built this observatory, and this observatory represents the god of the sun. It's a stellar observatory. And they experiment with a different type of archeoastronomy. It's not about posts, it's not about pillars, this is newer, this is about windows. Each window, if you look at this window here, this is called a jamb, right? So this is like an indentation. The window itself is here, but this is the jamb of the window. So what they used was not the window, but rather this outer extrusion of the window to align their view of the sky. So they use the edges of the window that protruded outward to get views of the equinox sunset, Venus, which was actually brighter than most stars at the time, and have an idea of how the cosmos works. And this was accurate, was pretty accurate, not totally accurate. Some people believe it's by coincidence, but that's the problem with archeoastronomy. How accurate really is it? How do we really know what they thought or what the ancient people believed? But it's off about by 1 degree, right? So their observation of equinox is off by approximately a degree of where the sun would actually, and this is associated with the date of creation, because the equinox and Venus in 3103 BC was marked the day of creation. And so that relates back to that religious purpose. And so therefore, these are some resources and references I've used. The main book is Echoes of the Ancient Skies. I love this book. Highly recommend you read it. Archeoastronomy, Introduction to Science of the Stars, Celestial Geometry. And I also use the internet. I didn't cite any particular sources. If you look at my notes, they have a couple of those, but that's it. Thank you.